Okay, item B, intrinsic geometry, exterior algebra in 3D. Could be 2D, could be 4D, and so on. Now, B part 1, manifolds. B part 1, lecture 17. Now, transition function, okay? Then, 2 manifolds and 4 charts. See this figure here? It's very important for you to understand. You see, this I have, it's important for you to go back in previous lectures and learn, okay, about transition function. Because every steps that are there, we can just use over here. So that's crucial for you to learn first lectures 14, 15, 16, you see? Just to understand clearly what's going on here. Now, you know how to construct, okay, a chart U sub x and U sub y. You just look at here, and this is non-map alpha sub x, non-map alpha sub y. Here, non-function, a mapping function. This is from point P to point Q. See, that's a function. And I'll have some detail here which I didn't emphasize in the previous videos. That is, attention now, points P, P prime, and P double prime. You see points P, P prime, and P double prime. They belong, okay, to the same point at the manifold. That's very important, because this I show separately, but always knowing that this point P, P prime, and P double prime, they belong to the same local coordinate in the manifold M. Okay, this comes from the manifold M. Let's put here. That's a manifold M3. This is manifold M3. The function f is important here. You see, there is an intersection of points. They belong to the chart U sub x and U sub y. Those points over here, they are in the intersection, okay, of these two charts over here. And f acts on this intersection here. Since P belongs to this intersection, so this is a point Q, okay? F maps a point in the manifold M to the manifold N. That's important. So, all this we already showed in previous videos, okay? Now we play these two together, okay? That's quite clear. So these are the Euclidean coordinates, okay, for the points around point P prime. And these are Euclidean coordinates around point P double prime that comes from the mapping from P to P double prime through this alpha sub I. The same here. Okay, now we are in the manifold M3 is analogous to this one, okay? So these are the coordinates of point Q prime, okay? And that's point Q, that's point Q prime. Attention now, this is a chart V mu, and this is the chart in case V nu. You see? This is V me and V nu. I think there is a V prime nu. See? Now, I'm sorry. This is a V prime mu. Is right. V prime nu is just this case. This will come from V double prime. See, double prime is related to alpha nu, and prime is related, first prime, you see, single prime is related to this V mu. So this is clear, analogous to this one. Now, there's a very important point about this mapping F over here. Okay, the F acts, okay, and this intersection belongs to M3 and map to another intersection belongs to the manifold M3. That's why, okay, I mark here in the red region, okay, over here. So F acts between intersections, okay, on the manifold M and the manifold N. So this is important, you see. We use F in the previous video, but I emphasize this property, okay, of this mapping F. So again, what we did before in previous videos, P belongs to M3, is representing two charts U sub X and U sub I. A map F, attention now, see, it maps M3 to N, but the region over here is the intersection. That's an important emphasize, okay, I'm emphasizing this over here. So this F, you see, it maps point in the intersection UX, UI to the intersection of this manifold. Takes point P to point Q. See? Now, this is where belongs to the intersection of the two charts, V sub mu and V sub nu, V me and V ni. We define coordinate transformation as we did before, alpha sub X and alpha sub I for M3 and alpha me and alpha ni for N, okay? Steps, local representation, this is local representation here, okay? In UX, the coordinates are x1, x2, x3, UI, y1, y2, y3, related to this point over here by a smooth transformation. Attention now, you see, this chart, to construct this chart, we can relate, as use in this smooth transformation, okay, as we did before. Now, likewise, we are going now to the right-hand side, let's say that. V me, the coordinates of Q are me1, me2, and me3. In the chart V ni, the coordinates of Q are ni1, ni2, and ni3 related. Attention now. These coordinates must be related to the coordinate, let's put one way here, me1, me2, and me3 by another smooth transformation. You see? Now, mappings, we have all the maps over here. You just look the notation here and see what is written here. See, alpha x map P to P prime. These are the coordinates of P prime. Alpha y, P to P double prime. These are the coordinates. You just see here, you say, and see there, and compare. Likewise, alpha me, Q to Q prime. Eta 1, eta 2, eta 3. Now, alpha ni, Q to Q double prime, C1, C2, and C3. Now we can use the composition. See, for instance, it's important here, as I emphasized before. For instance, I want the coordinates on the region where P double prime lives, the region, you see, and I want to map the region where P prime lives to the P double prime lives. It's important here, attention now, alpha inverse P prime belongs to E of X. You see, this belongs to E of X. But alpha Y must be applied to a point, okay, where it lives, attention now, it lives right over here. That's why the intersection plays an important role here. For points belong to the intersection. See, that's important here. So I only can obtain P double prime for points belong to the intersection of U sub X and U sub Y. See? Now this is Q double prime. You just look here. It's quite easy. You have Q double prime. You start from P double prime. See? So I have P double prime. This is alpha Y minus 1. Then I apply F. Easy. And then I apply alpha nu. You see, let's put the alpha nu here. So this path